So now we have discussed one problem in the previous video. The same problem we are solving it now by using method of sections. So if in a question certain members are given, now you can see that here in this question it is given find the forces in only BE, BC and FE. So only these three members, or we can say forces in these members, we have to find. We don't have to find out the remaining forces in the members. Only these three are required. Then in this case what we'll use? We'll use the method of sections. So the first step, as we know in method of section, is to find out the reactions. So we won't be seeing this right now. If you want to see it, you can see it in the previous video. Here I have explained it how to find out. Okay. Now the second step is to draw the section. Okay. Now the section is drawn here. Remember that the section should not be cutting more than 3 members. Okay. The maximum number of members a section should cut is 3. So you can see here 3 members are being cut here, that is BC, BE and FE. So the second step is done here, drawing the section. Now once we draw the section, we will consider only the left hand side portion of the section. Okay, so the left hand side of the portion, you can see I have drawn it here. The remaining portion is not necessary. So if I draw it with the dotted line, this is point C. This is point E. And these are the remaining things. Okay, so this everything which is on the right hand side, it is of no use. We are only considering the left hand side portion. Now you can see that this section is cutting these 3 members. So whatever the members it is cutting, you have to take the forces from that members. So I have denoted here the forces FBC, FBE and FEE respectively. Now remember, in method of sections, these forces are directly the member forces. These are not the forces on joints. So if it is coming as positive, then it will be in tension. If it is coming as negative, then it will be in compression. So first now we will apply sigma MB is equal to 0. So this is point B and we'll apply sigma MB is equal to 0. So you can see that FBC and FBE, these both are passing through point B only. Even 100 is also passing through B. That means the moment of these three forces will be equal to 0. Now what are the remaining forces? 80, 93.33 and FE. So using the moment equation, 93.33 into 4, so this is 4, this is also 4. So 93.33 into 4 minus 180 into 4 minus FE into 4. So by doing this, we will get the value of FFE is equal to 13.33. As it is coming as positive, that means it is in tension. Similarly, second, we will use sigma ME is equal to 0. Now you can see this E point is this point. It is not present in the section, but however it is present in the main structure. So why we are taking this point E? Why not point C? Because you have to take such points, moment about such points where the two forces are, or we can say where the maximum number of forces are passing through that point. If a force is passing through the point, then what will happen? We know the moment formula is force into distance. If this distance is 0, then no matter whatever the force is there, the moment will also be 0. So when this distance will be 0, when the forces will be passing through that point. So in the first case, you can see that FBC and FBE, these two forces were passing through point B. So first we have taken point B, sigma moment B is equal to 0. Now what is the another point from where the two forces FB among these three are passing through the point? So this is point E. So we are taking now sigma ME is equal to 0. Applying the same moment, we will get FBC is equal to minus 86.66. Now it is coming as negative. So this negative means it is in compression. So 86.66 compression. Now after using these two conditions, if there is one unknown force which is to be calculated, then we have to use the basic conditions of equilibrium, that is sigma Fx or sigma Fy is equal to 0. Now in this case, we will be using the sigma fx is equal to 0. So for using the sigma fx is equal to 0, we have to take this diagram and see in x direction whatever the forces are acting. So which are the forces that are acting in x direction? So FBC is acting, AT is acting, and a horizontal component of BE is acting, that is FBE cos 45. So we'll write it AT, this is AT plus FBC plus FBC plus FBE cos 45 plus FBE cos 45. So there is one more force which is present, that is FFE. This is also in horizontal direction, so plus FFE is equal to 0. Now solving this, we will get FBE as minus 9.43. Minus sign, that means it is in compression. So FBE is minus 9.43 compression. Summarizing all the values here in force table. So these forces in BC, BE and FE is respectively this, and the nature are given here. So this is how you solve the problem by using the method of sections. Remember few things while solving the problem by method of sections. First thing is to find out the reactions. Second thing is to consider or draw a section. While drawing a section, just remember that it should not cut more than 3 members. And also it should cut the members of the forces that are asked in the question. So in the question BE, BC and FE is asked. So your section should cut these 3 members. Then how to decide about which point the movement should be taken? You pay attention to this diagram or the section and see among the unknown forces. What are the unknown forces here? BC, BE and FE. From which point these 2 forces are passing? Out of 3, if 2 forces are passing through one single point, you take the movement about that point. So here you can see point about point B. BC and B, these 2 forces are passing through point B only. So you can take about B. What about point F? How many forces are passing among these 3? Only one force is passing, so we will not take about point C. What about point E? Yes, about point E you can see BE is passing and FE is also passing, so we will take point E. So these 2 equations we have got, MB and ME, and at last we will use sigma fx is equal to 0 to find out the last force in the member.